Hello, I hope all is well. Today I'm going to be going over problem 20 of the final exam. The problem states that a bank has kept records of the checking balances of its customers and determined that the average daily balance of its customers is $300 with a standard deviation of $48. A random sample of 144 checking accounts is selected. Now, this problem has four parts. And the main equation that we're going to be using today for this problem is z equals, in parentheses, x minus mu, n parentheses, divided by parentheses, the standard deviation divided by the square root of n parentheses. Now, the x in this problem is going to be the observed value that we're given for each part. So for part A, for example, it's going to be 306.6. The n is equal to the random sample value, which is what we're given. In this problem, it's 144 checking accounts. So we're going to be using 144 for that value. For the mu, it's going to be the given average that we have. So in this case, it's going to be 300 that we're given. And again, that's just what the problem has given us. And then finally, the standard deviation, which once again, it was given to us at 48. So for part A, it asks, what is the probability that the sample mean will be more than $306.6? Now, using the equation that I had stated before, we're going to do 306.6 minus 300 divided by 48 divided by 12. Now, calculating that all out, it'll give us 1.65, which is going to be our z value. Now, the other important part of these problems is going to be using the z-value chart in Appendix B of the book. That will give us the probabilities for each z-value that we have calculated. So in this case, 1.65 is equal to 0.9505, which is the probability. And since in this case the problem is asking more than 306.6, what we actually have to do is do 1 minus the probability that we were given, in this case 0.9505, which will give us a final answer of 0.0495. And that is going to be the answer for A. For B, it asks, what is the probability that the sample mean will be less than $308? Now we're going to be using the same equation. So it's going to be 308 minus 300 divided by 48 divided by 12. And that would basically be 8 divided by 4, which is equal to 2.00. And then once again, using Appendix B in the book, we're going to find that the 2z value is equal to 0.9772. Since less than is requested, we don't need to do anything else. The 0.9772 value is the value that we need, given that the problem has asked for less than. So 0.9772 is the final answer for that part. For part C, it asks, what is the probability that the sample mean will be between $302 and $308? Now, luckily, we only have to do technically half of the work because we already found the probability for $308. So that means we just have to find the probability of $302 occurring. So we do that by using the equation again. We do 302 minus 300 divided by 48 divided by 12, which will give us a value of 0.5. And then using Appendix B, the Appendix B chart, we find that 0.5 is equal to 0.6915 probability. And then since it's between 302 and 308, we just simply have to just subtract the two to find the value in between both of the z values. So we find that 0.9772 minus 0.6915 is equal to 0.2857, which would be our final answer. And again, that 0.9772 is from the previous section, the previous problem, the B problem. And then finally, it's going to ask us, what is the probability that the sample mean will be at least $296? So once again, we're going to use that same equation, x minus mu divided by the standard deviation divided by the square root of n. And we're going to find that 296 minus 300 divided by 48 divided by 12 is equal to -1. We're going to use Appendix B to find that -1 is equal to 0.1587 probability. And when this problem says at least, that means that it's greater than. So since it's greater than, we have to use the 1 minus the probability. So in this case, it would be 1 minus 0.1587, which is equal to 0.8413, which is our final answer. That is it for my problem. Thank you for a nice course, and enjoy the rest of your day. Thank you.